Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P0651, is indicative of a malfunction related to the sensor reference voltage B in the 2011 to 2015 Honda Civic models. This error signals an issue within the voltage reference circuit provided to critical sensors that relay vital information to the vehicle's engine control module, ECM, or powertrain control module, PCM. The affected sensors include the input shaft speed sensor, throttle position sensor, APP, AC pressure sensor, fuel rail pressure sensor, and fuel tank pressure sensor, FTP. These components are integral to the vehicle's operation, impacting aspects like engine management, fuel efficiency, and climate control performance. When the reference voltage is unstable or missing, it can compromise the vehicle's performance metrics and trigger the P0651 code. Proper diagnosis is crucial to restore function and ensure the reliability of the vehicle. The DTC P0651 refers to a malfunction within the reference voltage circuit B of the sensors attached to the vehicle's ECM or PCM. This circuit is vital as it feeds multiple sensors with a consistent voltage supply, enabling them to operate effectively and relay accurate data back to the controlling module. The input shaft speed sensor, APP sensor, AC pressure sensor, fuel rail pressure sensor, and FTP sensor are the primary components impacted. Each of these sensors performs essential roles like measuring vehicle speed, throttle position, refrigerant pressures, and fuel system statuses, which are crucial for optimal engine functioning. The reference voltage is typically generated by the PCM and is essential for the health of these components. A malfunction can lead to various operational issues, such as poor acceleration, engine stalling, or malfunctioning climate controls. Several potential causes could lead to the activation of the DTC P0651. First, faulty sensors that are unable to operate within voltage specifications can contribute to this issue. These include the input shaft speed sensor, APP, AC pressure sensor, fuel rail pressure sensor, and FTP sensor. Additionally, poor connections or loose terminals at the PCM or any of these sensors can interrupt the reference voltage supply. In many cases, checking for these loose connections or damaged terminals is a quick initial step in diagnosing the problem. Furthermore, shorted wiring in the VCC, voltage circuit control lines, can also result in this DTC being triggered, signaling that a wiring inspection is crucial. Addressing these possible root causes can resolve the P0651 code effectively. The activation of DTC P0651 can manifest in a variety of symptoms affecting the vehicle's performance. Drivers may notice engine performance issues, such as stalling or lagging acceleration, primarily due to inaccurate data being relayed from the affected sensors. Warning lights may appear on the dashboard, indicating to the driver that an underlying issue exists that requires attention. This could include the malfunction indicator lamp, MIL, or other alerts related to engine management systems. Additionally, the throttle response may become inconsistent, leading to erratic driving experiences or difficulty in maintaining speed. Overall, if these symptoms are observed, it signals an essential need for immediate diagnosis and repair to ensure safe and optimal vehicle operation. The first troubleshooting step in addressing DTC P0651 begins with a clear initiation of the diagnostic process. Start by turning the ignition switch to the on position, which powers the vehicle's electrical systems without starting the engine. The next step is to utilize the Honda Diagnostic System, HDS, to clear the DTC from the system memory. This is essential for resetting the vehicle's diagnostic pathways to ascertain if the issue persists. After clearing, check for any pending or confirmed DTCs once more using the HDS. If DTC P0651 reappears, it confirms the failure has been duplicated, prompting movement to the next step in the troubleshooting guide. However, if no DTCs are indicated, it may suggest an intermittent failure, directing attention to possible poor connections or loose terminals at the PCM and sensors. In the second troubleshooting step, the goal is to determine the failure area potentially contributing to the DTC P0651. First, turn the ignition switch to the lock position to ensure all electrical systems are powered down. Next, disconnect the connectors from each of the specified components: input shaft speed sensor, APP sensor, AC pressure sensor, fuel rail pressure sensor, and FTP sensor. This step isolates the sensors and allows for further testing without interference. Once disconnected, turn the ignition switch back to the on position. Subsequently, clear the DTC again through the HDS and check for pending or confirmed DTCs. If DTC P0651 appears again, it indicates a continuing fault, advancing to the next troubleshooting step for further diagnostics. If not, inspect the connections and wires for signs of damage or loose fitting before beginning the initial testing process again. In Step 3 of the troubleshooting guide, initiate a shorted part check. This step involves systematically reconnecting each sensor, starting with the input shaft speed sensor, followed by the APP sensor, AC pressure sensor, fuel rail pressure sensor, and lastly, the FTP sensor. After reconnecting each sensor, use the HDS to check for pending or confirmed DTCs. If DTC P0651 is indicated after reconnecting a specific sensor, it signifies that the sensor in question is most likely malfunctioning and replacement is necessary. Conversely, if no DTC appears after reconnecting any of the sensors, the next logical step includes inspecting for poor connections or loose terminals at the PCM and all the previously mentioned sensors, ensuring comprehensive fault identification. If all connections are found to be sound, revert to the first step and reassess. The final troubleshooting step focuses on checking for shorts in the wire within the VCC lines. Begin by ensuring that the ignition switch is in the lock position for safety. Then, jump the SCS line using the HDS before disconnecting the PCM connectors A and B, ensuring to maintain a controlled environment. Test continuity between designated test points and the body ground to validate the integrity of the wiring. Test points include the connectors for the input shaft speed sensor, APP sensor, AC pressure sensor, fuel rail pressure sensor, and FTP sensor, alongside both PCM connectors A and B. Evaluating each circuit for continuity allows for the identification of shorts between the identified terminals and the components. If continuity exists, it indicates a wiring fault that requires repair. If continuity does not exist, the issue may lie within the PCM itself, necessitating an update to the latest software or substituting with a known good PCM. Final repair verification is crucial to confirm that the diagnostic process has resolved the DTC P0651 issue. Begin by ensuring that all connectors that were previously disconnected during the troubleshooting steps are reconnected securely. Once all connections are restored, turn the ignition switch to the on position, ensuring the vehicle systems are operational. Utilize the HDS to reset the PCM, which clears any residual fault codes and establishes a fresh start for the vehicle's diagnostic pathways. Following this reset, check for any pending or confirmed DTCs to ascertain whether the P0651 code has been resolved. If DTC P0651 is still indicated. Further investigation into loose terminals or damaged wiring may be needed. If no codes are present, the repairs are deemed successful, and it indicates that the vehicle is functioning properly. While troubleshooting the P0651 code can address immediate concerns, preventive maintenance can significantly reduce the chances of recurrence. Regularly inspecting wiring throughout the vehicle is recommended, especially in high-movement areas that may experience wear or damage over time. Ensuring all electrical connections, particularly at connectors for sensors and the PCM, are clean and secure prevents potential issues from developing. Additionally, keeping the vehicle's PCM software up to date optimizes performance and can forewarn of issues that may arise from outdated software. Incorporating these preventive measures can enhance the longevity of sensor components and reduce troubleshooting occurrences, ensuring the vehicle operates smoothly for years to come. In conclusion, understanding DTC P0651 is vital for maintaining the performance integrity of the Honda Civic from 2011 to 2015. This code reflects issues within the sensor reference voltage B, underscoring the significance of the associated sensors that contribute to engine management and overall vehicle function. Following a systematic troubleshooting approach allows for an accurate diagnosis, identifying the root cause of the problem effectively. Each step builds on the last to ensure a thorough investigation, safeguarding against future issues. Finally, adopting preventive maintenance strategies will further mitigate the likelihood of encountering this code again, leading to a more reliable driving experience and clearing potential frustrations associated with engine performance inconsistencies. Please like and subscribe to the channel. See you next time.